DC-DC converters perform a diverse range of tasks. They adjust voltage levels, as well as regulating, stabilizing and isolating them. So what are the advantages of the new Quint Power DC-DC converter with SFB technology? Firstly, it stabilizes fluctuating voltage sources and compensates drops in voltage on long cables. Secondly, independent supply systems can be integrated thanks to safe electrical isolation. Thirdly, SFB technology ensures swift triggering of standard circuit breakers through dynamic power reserves with up to 6 times the nominal current for 12 milliseconds. The fourth benefit, heavy loads are reliably started by the static power boost power reserve with 1.25 times the nominal current. The final benefit is that the preventative monitoring function reports critical operating states before faults occur. This is implemented through continually monitoring the output voltage, output current, and input voltage. The case contains a DC-DC converter. An adjustable power source, a battery, is being simulated here, as well as various cable lengths and loads. Let's select the battery as the power supply. Let's connect the load directly without the DC-DC converter and vary the input voltage. The load voltage varies. In the case of particularly low voltages, below 20 volts, sensitive loads no longer work reliably. Let's connect the DC-DC converter between the battery and the load. In spite of the adjusted input voltage, the load voltage remains consistent. Sensitive loads are reliably supplied power. Now let's switch over the power supply. The power supply is now our power source, so we measure the input and output voltages at various loads and cable lengths. At a load current of 5.2 amps and a cable length of 80 meters, the voltage is interrupted at the DC-DC converter input to below 17.5 volts. The vast majority of loads would no longer work reliably. But with the DC-DC converter, we can refresh the voltage. The load is continually supplied with 24 volts. The DC-DC converter can also integrate independent supply systems. Let's start without the DC-DC converter and trigger a short circuit at the load. The voltage at the power supply unit is interrupted. Let's reconnect the converter for the experiment. With the DC-DC converter, the voltage at the power supply unit is no longer interrupted. It electrically isolates the system, isolating the fault. Electrical isolation also enables grounded systems to be isolated from non-grounded ones. As the first of their kind in the world, Quint Power DC-DC converters are equipped with patented SFB technology. In the event of an error, the circuit breaker is triggered swiftly and safely. Only the defective current path is selectively shut down, while the rest of the system continues to run. As such, the SFB technology dynamic power reserve supplies 6 times the nominal current for 12 milliseconds. SFB technology can be deactivated using a switch on the top of the device. This is necessary if the power supply unit in use is overloaded with SFB pulse supplies. For example, from an independent power supply unit. When supplying from a Quint Power SFB power supply unit or a battery, the SFB technology can remain activated. Once more, the static power boost power reserve smoothens the starting of heavy loads. Up to 125% of the nominal power is permanently available. The preventative function monitoring outputs warnings of device failures in good time. Similarly to the Quint-Power power supply units, boost and DC-OK signals are output at the DC-DC converters. If the nominal current is exceeded by increasing the load current, this is indicated by means of the boost LED and a corresponding output signal. Furthermore, a drop in the output voltage by more than 10% is reported by the DC-OK signal. A new feature of the DC-DC converters is the input-low input voltage monitoring. Let's use the battery as our source. If the input voltage drops below 19.2 volts, this is indicated by the input low signal, which is also provided as an output signal. The battery can thus be protected against deep discharge, an absolute must for all battery applications. Here's another summary of the benefits of the new Quint-Power DC-DC converter with SFB technology. Firstly, the converter stabilizes fluctuating voltage sources and compensates drops in voltage on long cables. Secondly, independent supply systems can be integrated thanks to safe electrical isolation. Thirdly, SFB technology ensures swift triggering of standard circuit breakers. The fourth benefit, heavy loads are reliably started by the static power boost power reserve with 1.25 times the nominal current. The final benefit is that the preventative monitoring function reports critical operating states before faults occur.